So in this session, we would try to look into resource management. So as we all know, so we have learned about like basics of C++. So what is the structure of the C++ code, then how to define, how to write classes, how to test them. Then we have learned about compiler generated functions to operate on various objects that will be created from the classes. Now, next thing is like we need to look into how exactly these resources can be managed. And when I say resources, then there are a lot of things. It's just not the memory. It's also about like thread that we create. It's also about the file that we open and close, and like matrix and a lot of things. So this chapter is where we would be learning about how to manage those resources, know the tricks to do that. Okay. Again, like all the information about this chapter is added over here. So inside this .md file, you could just go inside this thing. You could read about resource in this resource management. Basically, we call means heading of the chapter is like resource acquisition is initialization. Because whenever we say like okay, I am using resource, what does it mean? When does we understand okay resource is being used? So basically, whenever we are like acquiring any resource, at that time only we are saying okay we would be using this resource, and whenever we are like destroying that object, at that time that resource would be freed. So resource acquisition is itself is considered as the initialization of that resource, and then we need to learn how exactly to manage it. Okay. So in this chapter, first of all, we will look into what are the resources that we need to think about. So as I mentioned, so resources could be memory, it could be like files that we open and close, or it could be like threads that we create and like join. But the thing that we need to keep in mind is like whenever we use any resources, those resources after acquisition has to be disposed. Otherwise, they would lead to like some sort of like mismanagement in memory, and that's not good. Or they might lead to some sort of leakage. Okay, so that's the reason resource management is really important. Um, so as I mentioned, there are like three, four types of resources that we need to look into. First is the memory. Second is file opening and closing. That's the reason they say like when you open file that should be closed. Okay, and there are like certain trays that ensures like when file is open and when that particular code is like close. If close is get called like by default, so that that file would get closed, so that that resource would be released. Same thing about like threads, and same thing is about memory. But this session we would focus more on like memory management. So we would just try to understand how exactly this memory management would work. So when we say like memory, so we have like two types of memory. I mean, I'm just talking about like RAM. So on RAM we have like stack and we have a heap. So stack is like memory where like we would be like stacking information, I mean stacking uh, values one after another. And yeah, so last in first out principle would be the way in which we would be like releasing that information. Okay, or releasing those resources. And then we have heap. So heap is something where we could dynamically allocate those memory locations for certain resources. We could use them and we could release them. But stack is something would be means used frequently and would be cleared automatically. But this dynamic memory locations like this heap, whenever we like allocate any resources, we need to be sure that we deallocate or we release those memory location. Otherwise it would lead to memory leaks, and that's not the good thing. Okay, that means that memory something has gone out of scope when we like lose that handle. So this is like important thing about like resources or memory. Next thing is like what are the issues that might happen with like memory or resources that we have. Let's just talk about like memory. First thing that might happen is like memory leak would happen. Okay, so what would be the memory leak? Memory leak is like you could see over here. So inside main function, what we have created integer pointer x, which is pointing to like some location on heap, and we are allocating one integer memory location over there. Okay, and then at next moment we are pointing that pointer to like null pointer. So the memory that has been allocated on heap, we have lost handle to that location. Okay, but that look on that memory has been like allocated to some part, and we would not be access that memory since we have like moved that handle to null pointer. So that memory would still be there, and that means like that memory location would not, we would not be able to use that memory further. So that leak has occurred, and to avoid that thing, what we need means we need to take like some precautions. So memory leak is some one thing, means one thing. And like it happens when we like lose handle to that memory location. I mean, this is just the one way. Another way could be like whenever we create object and some exception occurs. So in that situation also, we would not be able to destroy that thing, and that memory would be like uh, we would lose handle to that location, and leak would happen. Okay. Next thing is like double disposal. Like we are pointing to this memory location. So like we have like this memory on heap. When we delete, that means like that memory has been deleted, and when we try to delete it again, so it would give like undefined behavior because there is nothing to delete, okay, over there, because it already has been like deleted. So this is like double disposal is like another issue that might happen with memories. And third is like uses after disposal. So we have disposed it, and now we are trying to assign that thing to like another variable. So we might be able to, so when we delete it, so it would become 0 since it's a pointer, but the value, so let's say over, I would explain that thing in the code, but it means when we try to assign it to the variable, the value that we try to assign over here might be different after deletion. So when we try to use it after deletion, that would be like totally undefined behavior. So these are the issues that would happen. And to avoid these issues, first of all, we need to use certain tricks, okay? And this is something is all about like resource management. How exactly we could avoid like leaks, how exactly we could avoid double disposal, how exactly we could avoid these uses after disposal. So first of all, we need to understand object lifetime, like how exactly objects are being generated. Okay. So there are like three ways in which objects are created. So in case of the C++ programming language, whenever we write any class and we try to create instance of that card, that would be like object, and we would be having like constructor, and then we would be calling. Means first of all, we would be creating data members, then you would be creating like calling constructor, and like then like other methods in sequential order, and then at the end of like scope we would be like doing like this we would be calling the constructor. So basically during this entire time when we call constructor, so we would be creating instance of that class, and that would be like object. So when our object acquires memory, so at that time we like lifetime of that object starts, and when we call destructor at the end of like that main statement, we lose that or we release that memory. So all the time when like that object is in our memory and we could access it with like certain handle, that would be considered like object's lifetime. Okay. So object lifetime is the lifetime of object, refers to the period during which object exists in memory and during which we could use it by the program, or it can be accessed by the program. So there are like three types of memory. It means storage durations. First is like automatic storage duration. Let's say we have like some sort of if else code or like for loop, and when we go inside that curly bracket, so we try to take some information, we store it on stack, and we keep it on stacking, and then when that curly braces closes after, I mean, at the end of that for loop, we try to destroy all those variables that we have stored, okay, on stack. That is the automatic storage duration. Means after some time that would be like destroyed whenever that object is like, means whenever we enter the like, or like whenever we reach the end of that block, and that's something represented with the curly braces. Then there is a means automatic storage duration. Means we don't need to have like another thing to take care of that memory deletion thing, okay, or release thing. Second is like dynamic memory allocation. So automatic storage allocation that will happen on stack and for like for loop and all that stuff. Then there is a dynamic storage location. So basically, this memory, dynamic memory, is something would be allocated by the programmer using a new keyword or something like that, and that would be allocated on the heap. So in that situation, programmer has to take responsibility to release it. If he is not releasing it, so yeah, object with dynamic storage location are created using dynamic memory allocation functions like malloc, new, and exist until explicitly deleted by the corresponding deletion function like delete or free. And that is something supposed to be done. So this is a dynamic storage location, and then third is a static storage location. So this is static storage duration is when like this main function start and it exists until like this main function ends. Okay. So this is like three things that we have, like automatic storage duration that would be on stack, and that would be there. The dynamic storage duration is something we have to take care by ourselves, like programmers supposed to take care of that. And then there is a static storage duration. Static duration would also be taken care of by stack. But if it has like some reference to dynamic memory, then in that situation it would have like some trouble. So, but these are like three storage durations that we have, or object lifetime that we have, and dynamic storage duration or like dynamic object lifetime is the only place where would have like this, means other places also would have leaks, but this is like major chunk where we could have like this resource mismanagement. We could lose handle, we could double dispose it, or we could try to use it after disposal. So this is the object lifetime that we have with us. And there is a construction order, like means as I mentioned. First of all, we started like base class, then data members and constructor would in another object. And destructor would be called at the end of the main function, and it would fall in a reverse order. First of all, destructor would be called, and then like other objects would be like destroyed in like subsequent order in reverse order actually. Yeah. So that's the thing. That is the object lifetime. Okay. So we learn about resources, what issues might happen, object, what is the object, and what is the object lifetime. Okay, and what are the storage duration, and where object lifetime might lead to these resources issues. So thing is that if you see like the simple code over here, so it's about resource acquisition and initialization. So over here, we have like this struct a thing, okay, and then there is another struct x which calls like this struct a. So here we are able to acquire resources for a, but when we try to acquire resources for b, there exception occurs, and we would be able to release resources for b, but we would not be able to release resources for a. Okay, so resource a is like we lose handle to that, and that memory location is like means that is a memory leak. Okay, so to avoid that thing, there is a principle which is called like single responsibility principle. Means like one object should have responsibility for like um, one resources only, and if that is the thing, then you will be able to like means destroy that object very easily. In this situation, like this object x has like responsibility to destroy two objects like a and b, and that was quite difficult. So that's the reason this memory leak happened whenever that exception occurred. And to avoid that thing, there are like certain tricks that we need to use. And first trick is like we have to explicitly mention this new and delete thing everywhere. Okay, means even if like some exception occurs, we should be able to tell, okay, this is where like this there is like bad code go. I have added one example for that. But whenever like this exception occurs, we should have added condition over there. Okay, even if exception occur, using try and catch, we should be able to catch that exception. And whenever this exception occurs, we should be able to delete this resource. So if that is the case, then we would be able to like use or avoid this memory leakage very efficiently. So first of all, we should not have like no naked news. We should not have, I mean, so we should be using like vector, like the standard template library packets, because they are developed in a such a way that like they would not cause any sort of leakage. And third is like use like this smart pointers. Okay, so we have two types of pointer: unique pointer and like shared pointer. So basically, thing is that like means whenever we create any object on like on this heap using these pointers, so instead of just creating them using like this raw pointer, thing is that like we try to provide some sort of wrapper around them, okay, in the form of like this smart pointer. So basically, the smart pointer, what they do is like what they do is like basically they try to ensure. So first of all, they try to okay, let me do that. So the standard unique pointer object, the smart pointer, this take like it takes enough ownership for that object. Okay, the object that we try to create on like heap, and whenever it goes out of like out of scope, it would automatically delete it. Okay, when it goes out of scope or is reset. So that's like unique pointer. So unique pointer is like something whenever we want to manage only one resource on heap. Okay, so even means whenever this exception occurs or something like that, if you have like this unique pointer over there, it would be able to delete that resource and release that resource very effective. Delete that object and release that resource effectively. Okay, that's the unique pointer. If there is if we have like some memory location that has been referenced by like more than one like variables, so that would be like shared location. Okay, so in that situation we could use like share pointers. So in that situation, what happens if like all the pointers like lose handle to that location, then no one, if no one is like taking responsibility for that memory location, then that memory would become like leaked one. And to avoid that thing, what we need to do, we have like share pointers. So share pointers have like shared ownership of that memory location, and that ensures like whoever is like last owner of that memory location, whoever is pointing to that memory location lastly, has a responsibility to delete that resource. Okay, that is a share pointer. Okay, so that's the thing. And then we have like this make unique and make shared. So basically these are the templates, and using them we just ensure that like whenever we are like means make shared and make unique basically are the ways in which like this unique pointer and share pointer are supposed to be like created, because in that situation there would be like no leaks, and yeah, means they would be like more efficient. But just need to keep in mind it like this, these are just the way to create like unique pointer and shared pointers, so that we could avoid leak further. So that's all about the chapter. Now we would try to get into like examples, and we would see like how each of them like go out of this thing, resource spelling, this everything. So I have like this. So what we saw inside resource management. So when we talk about C++ programming language, there would be like various resources. It could be memory, it could be like thread, it could be files. So we need to make sure that like whatever resource we, whenever we want to use any resources, they would be using like some sort of memory. And whenever we are done using them, we should be release it. Then and then only we would have like efficient uses of memory. That's like our purpose behind resource management. But there are certain issues that might occur. Okay, first is about like leakage. So we have like this preprocessor directive, and we have like main function over here. So I have created pointer x which pointing to this like heap location, and I have like added like means I have at that location I have stored value 10. So when I do see out, it will be able to give me like this value x, and when I like point it to like null pointer, and if I try to get like value of x, you would see like what I get. So I get like 10 for like this first see out, I get value of x star x to be asterisk x to be like 10. But second time when I try to get that value, it says like, okay, means this like segmentation fault. And what it means, like whenever we get like segmentation fault, that means our x location is pointing to something, means x variable, we try to get information about that location which does not exist. Okay, so this x is like null pointer, and it is pointing to nothing. So in that situation we don't have to present anything, so that's the reason we are getting the segmentation fault. So that's the reason whenever they, and this indicate we have lost handle to this location where 10 has been stored, and we would not be able to release that thing. Okay, ever, means that memory is lost. So that's the memory leakage, means place where like this 10 is stored, it's still in a memory, but there is no way using which I could like release that time. Okay, and that something would like keep on consuming my heap, and eventually my laptop would become like slow. Okay, so that's the thing. So this is about like first memory leakage. So in this situation, if we are like pointing to some location on like heap, and if we suddenly point to like next location, so we would lose handle to like this 10, and we would not be able to release it, and that's considered like memory leakage. Second is a double disposer. So if I like just, so you would see like means what I'm doing over here. So I'm pointing, I have created pointer which point like heap location. I store 10 over there. I print it, so I get 10. I delete it first time. So when I delete it and when I try to get that x value, dereference x value pointed by that pointer, I get 0. Okay, because that's beauty. So means since there is a pointer that has been like that x is like initialized to like default value of 0. But second time when I delete it, and when I tried to get that thing, so it says like double free detected in thing, and that's the reason it has been aborted. So the double disposal would also give like some issues. Okay. Third is users after disposal. So let me run this thing as well. So over here, I have like same pointer x integer pointer created which points to location on heap. I stored value 10 over there. I printed it, then I deleted it, and then after that I tried to uh, like transfer this value of 10, like assign this value of 10 to like a new variable y, and then I try to print y. Okay, so value of x asterisk x over here is like 10, so I wanted to transfer value of 10 to like y, but the value that I get over here is like for first see out it's 10, I deleted it to I get like value to be 0. But when I try to assign it to like another variable after disposal, I get like undefined behavior because I wanted y to be 10, but it is 0. So that's like uses after disposal is like undefined behavior. And these are the issues that might happen with resources. That's the reason we need to manage those resources properly. And that's when this object lifetime come into picture. So object lifetime is like whenever we have like any class or any data element, and whenever it acquire any resources on memory, it becomes like object. And until the point we are like releasing them, they would be there. They would be there, and that period between these two things, point when they have acquired that memory location, and the point where like they are releasing that memory location, would be called like object lifetime. And there are like three lifetimes. First is automatic storage duration, when means it's about like those for loop control loops, okay, or like something some sort of function. So basically, it's an automatic storage duration, and that would be means it would assign resources and it would also delete resources automatically. So because most of them would be on stack only, so it would happen automatically. Second is a dynamic storage duration, and that's where like we would be having issues. And then for a third one is a static storage duration. It's about like this int function, main function that we have, and it might also cause like leakage if we have reference to dynamic memory location. So second and third would have issues. Uh, Now we would also look into like what is the order in which like object is being created. So we have like one class person over here. First of all, we have constructor. So basically it takes name as input, and then it says like, okay, that name and person is born, and this destructor, second person dies, and then introduce I am. Okay, so this is like a member function, and then there is a private, by default everything will be private. So standard string name and integer. Okay, so inside main function what I have, so I have created object of like this class person called as Alice, and have provided argument to be Alice. So what is so first of all I have created argument means object Alice, then I have created a pointer um, of like class person, and it's also initialized with like Bob. Okay, but over here like means this thing is like normal. Okay, this thing is like this automatic storage duration. But this thing is like, since we are like storing it on like a heap, that would be on dynamic storage duration. Okay. And when we call it like Alice introduce and Bob introduce, so just see like this notation that we have here. We have like period over here, and we have like this arrow over here. So first of all, we delete Bob. Okay, so this is how we are supposed to release memory on like a heap. And for like automatic, we don't need to do anything. When we like do like this closes it, the static storage duration will be ended, and like we'll be able to get like this list lines. Okay, so when I run this code, okay, so you would understand sequence of like object creation. Okay, so first thing is Alice is born. Okay, what is Alice? Alice is a constructor. Okay, so means sequence would be, first of all, like base class would be created, then this data members would be called, second step, and third step would be constructor would be called. Okay, and after constructor other methods can be called, like this introduce method. So Alice is born, then we created like this inside main function we have like this Bob. So Bob is born, then we introduce Alice. So Alice introduces herself as, okay, I'm Alice. Bob says, okay, I'm Bob, and then we deleted Bob. So Bob is supposed to, then destructor would be called. Okay, and it goes in reverse order. First of all, it destroys first this thing, so Bob dies. Then all the resources that have been allocated, okay, to mean in reverse order. First of all, destructor would be called, then constructor information would be deleted like this. All the information that has been acquired inside this constructor body would be deleted. Then this name would be deleted, Bob would be deleted. So that would be like sequence in which it would happen. And then second thing, we return, and then Alice would die. Okay, Alice dies, and it would go in same order. Okay, destructor would be called, then that constructor would be called, and information would be released. Then this name information, Alice information would be released, and then it would go to base class. Okay, so Alice word itself is like last thing that would be released, means would be released last. Okay, so That's like object lifetime. This is just like simple example to give you like idea about how exactly object would be created, what would be sequence of object created. And this is like array means resource acquisition and initialization. So this is a bad code. So as I mentioned, so when we have resources, certain issues would happen, and those issues would be related to object duration or like object lifetime duration, whether it's like automatic storage duration or like dynamic storage duration or static storage duration. With a dynamic storage duration, then we have to ensure that like whatever object, I mean whatever resource that we acquire should be released. So over here you see like there is a do something function. So there is a bad code. So over here we are like pointing some memory location on heap, some adding some information from console, getting some information, and we are assigning some value to that extra I, performing some operation. But in performing this operation, if we get like some error, we need to catch it and we need to delete that I. Okay. Otherwise, that I would stay there and that memory leak would happen. Okay. And we need to throw that error. If there is if loop, so inside if loop as well, we need to ensure, okay, if equal to delete I and then return false. If not, then delete I and return false. So thing that I'm trying to show you over here is like whenever we call this bad code, in each of that sub loops, we need to ensure that like we are deleting resources, and that's like the good way. That way we could ensure like, okay, this memory leakage would not happen. But you could understand, okay, that would include like a lot of things. We at each moment we need to ensure like whenever we write like each loop, we need to ensure that like, okay, we should be like releasing that I resource, and best way to deal with that uh, would be to use like smart pointers. Okay, so we would be using unique pointers. So instead of using like raw pointer like integer star and I would be using like unique pointer standard, and for that purpose I need to use this memory library. So I would be using like standard unique pointer integer I, and I would be initiating with like this new integer. So whenever there is an error, I don't need to like delete that I. Okay. Over here also I don't need to delete that. So that thing would be taken care of by this like unique pointer. So whenever there is exception occurs, this unique pointer would have like wrapper around this rock pointer, and that would delete I. Whenever there is if loop, even if you don't go, even if you go inside this thing, and if you don't go like over here, like still would be able to like release that information. So that's like unique pointer that we have. Okay, and this is like best way of like resource acquisition and releasing. So that's something lead us to why do we mean how exactly unique pointers and like this shared pointer would be used. So unique pointers are, so whenever we are like acquiring any memory location or any space on like heap, so in that situation we manually need to ensure that like it would be deleted, and to get that thing atomized, we need some wrapper around raw pointer, and that would be like the smart pointers, and first is like unique pointer. So it would share ownership for that memory location, and whenever exception occurs or any sort of issue occurs, it would delete that memory, okay, and release those resources. So this is a unique pointer. So over here I have like this simple struct x struct file or like struct object, constructor destructor, and then simple unique pointer which takes in like this struct as the input, and then function f is called, g is called, and then over here first, over here we also need to provide like a unique pointer to be x, then and then only we would be able to like pass it to like this function x and g. Okay, and over here for g it's like copy assignment operation. Okay, so g open. So when I run this thing, okay, thing that I want to show from over here is there is nothing. I just want to show you like how exactly you could use unique pointers. So syntax would be like whenever you want to use, like it should be standard unique pointer. Then inside bracket you should have like what the type and then name, okay, x, and then the memory that you want to allocate. And you could use it like later on the way you want. But since it's a unique pointer, you also need to make sure like whatever function that you define, it should also be taking like same thing as the input. Okay, standard unique pointer x a constant ampersand x. Okay, and then only you will be able to use it. Okay, so when I run this thing, so first of all, constructor like this x would be called. Then another, since over here it's going in over here, So again, this f would be called, okay, f of x. In here, we don't have like any constructor called like new x, of that thing is not there, okay. So it just said, okay, this f is called, then this g is called, but before g, yeah, g is called, and after that, like this end of main, but before that, this destructor is called, okay. So destructor of x is there, okay? And then see out end of main. This is the sequence in which it is being done, because it ensures that like, okay, means we are like releasing those resources that has been like acquired over here by that x. So that's the way. Means we don't go for like this last stage. Even before that, we release those resources. Means whenever we are done using them, we release them. So if you go to like uh, so this is unique pointer. So you would be having like just one memory location that you need to take care of. And if any exception occurs or any like double dispose or like you just after disposal, so that thing would be taken care of by this unique pointer. And then there is a share pointer. Share pointer would have like share responsibility for some memory location. Okay. So for like we would be creating like share pointer of like type X, like X, and so this is just a function actually. So over here we would be creating like share pointer of type X, and there would be like two pointers of X1 and X2, and both of them would be like pointing to same memory location X1 only. Eventually, the same memory location on like this new X would be like same memory location that we would be having over there, because this new means this memory location on heap would be acquired by X1, and since like X2 X1, so by using copy assignment operator, X2 would be acquiring like same memory location. Okay, so both of them would be like they would be having like share ownership of that location pointed by X1. So using this X1 dot use count, it shows like how many like pointers are pointing to that memory location. So over here in the beginning, we have like two pointers, this X1 and X2 both. When I use like standard move X1, so I move X1 to F. Okay, so over here, so I try to means X1 would like lose ownership of that thing, and if I use like use count over here for X1, so it would show 0. And if I check for X2, X2 is still pointing that location, so it would be 1, and then end of main. Okay, so if I run, you see like X means first of all this thing, am I printing it? Yes, first of all X use count 2. Yeah, so it also shows like when constructor is calling. Yeah, actually we are going over here. So first of all, like whenever like we try to create this show pointer, constructor is called, then it is allocated to x1 and x2. Then this count is 2. Then function f is called. So ownership of x1 would be transferred to f, and now there would be like so ownership for that location to x2. So for like x1 use count, so x1 is no longer pointed to anything, it's 0, or x2 it would be like 1, then end of main, and then we would be like releasing those resources. Okay. So whoever left last, so x2 left last one. So whenever this happened, like whenever this main function ended, so this uh, destructor is get called. So this is about a shared pointer. So shared pointer is like means whenever like two or more pointers are pointing to one memory location, and when both of these pointers are like done, means gone, so we would lose like handle to that location, and we would be able not able to recover it. So to avoid that thing, share pointers are there. So share pointer, what they do is like each time they would have like count of how many pointers are pointing to that memory location. Whoever is the last pointer to that location would take responsibility to delete it. Okay, so whenever this x2 is going out of scope over here, so like this destructor is being called. Okay, so that's the thing. Then over here that you should remember is like we have created like a pointer which pointing to x. We I mean we implemented this function And when we implemented like G function, so basically we were trying resources from X to like this. So that's the reason there is no resources left, and that's the reason over here only the destructor is being called, okay, and then end of main happened. Means over here destructor first and then, because there is no pointer pointing to that location. That's the reason destructor is called before there. But for share pointer, it happened after end of main, because still there is one pointer that pointing to that location, and when like this static duration and happens like this end of main function, then only destructor is called. So that's about shared pointers. But thing is that like sometimes unique pointer or share pointer, though like means they are ensuring that like means they are deleting resources that are used by pointer using wrapper, but sometimes they might cause like some sort of leakage, and to, means in some situations, some rare situation, and to avoid that thing, there are a way in which like this share pointer can be or make pointer can be created, this unique pointer can be created. And for that purpose, best way is like to create those resources using um, means instead of creating them using like this unique pointer and something like that, unique pointer and something should be created using this make unique or make sure. Okay, so we would be using like means when we have to create like a unique pointer, so we could use a standard unique pointer person ptr1 equal to standard make unique and then this person and Alice. Okay, so it would be like same flow, but what we would be ensuring is like that unique pointer is created using make unique, and then share pointer would be created using make shared person Bob. So basically, this is just the template using which we could like create unique pointer or share pointer, and whenever those pointers goes out of scope, um, they would like release memory. But beauty about like this make pointers and make shared is that like they would be like means eventually they would be like referring to one location only, okay, even if it's like unique pointer or share pointer. So they would have like better control over that location, and they would be able to release resources very effectively. So there are no chances for like memory leakage. So whenever we have to define unique pointer, so try to define that thing with the help of like this make unique for anything. And whenever we have to define share pointer, try to define that like make share. Okay, so just we have to share and then type integer or person and then the argument. Okay, or like yeah, so this argument and it would be like created of like the time pointer. Okay, so it's just a way to like create it. Otherwise, everything is okay. So this is like make unique and make sure. So now we learn about what are the resources, what issues might happen like this leakage or like double disposal or reduce after disposal. We have learned about object lifetime, then what are the storage durations, automatic dynamic storage and static storage duration, then construction and destruction order. We learn about resource acquisition, single responsibility principle. We also learn about like this resource acquisition is initialization, means how exactly resources is acquired and how exactly is released and how exactly we can effectively deal with that using smart pointer. So means we could use like unique pointer. So to ensure that like whenever dynamic memory allocation happens, we release that memory using unique pointer. Whenever like two or more pointer pointing to the same location, we could like ask that responsibility to the last pointer, whichever is left, and that would like release those resources. And to avoid like certain issues with like unique pointer and shared pointer, we would be defining unique pointer and shared pointer using make unique or make shared, and that would avoid certain issues because eventually they would be just looking at one memory location, and that would give them like better control over it. So that's all about like smart pointer. I hope you all learned something useful from this session. If you need some more information, you could go to this markdown file, you could read thing over there, or you could come to this examples and you would get like better clarity about this. But this is all about like resource management. I hope you have done something useful from this. Uh, yeah. Thank you.